Welcome to this subtopic lesson on the engine starting for the Airbus A320. What we're going to cover are the components involved with the start system, and also look at obviously the indications on the ECAM display that are possible, and also of course start failures. We want to be familiar with what can possibly happen with the starting sequence, and then of course what happens when there's a failure detected. What is the system going to do? All right, so just to give you some names here of some of the components, we do have the start control valve. It's going to be the start control valve, and then the starter itself, and then also the fuel shutoff valves. Those are also participating in that whole start sequence. So you have those, and of course the ignition. But again, mostly it's going to be, we're talking about the main components of being the starter, control valve, and the starter. All right, so let's go ahead and get into this. Generally, what's happening, we're talking about a sequence that occurs when the engine master control switches are switched to on, and then that starts the process with starting. And what we're trying to do, the concept here is just get, you have the starter to essentially kind of boost and turn the engines to get it going up to a certain N2 speed, and after that then it's kind of not necessary to have that starter on unless there's a necessary application in flight for it to be restarted by the pilot. Okay, so in general we have some of the smaller components, or say smaller, they're part of the combustion, is the spark igniter, the exciter. I know I mentioned this before with ignition, okay, is that you have exciters that are providing have a power source, 115 volt, in which from there is transmitting these electrical pulses to the igniters, which are connected to the combustion chamber, and that all gets intermixed with that air fuel mixture in order for the combustion to occur and have that slow burning. So that's kind of that's the process that we're talking about. This is a pneumatic starting system that's driving that engine, high pressure rotor. Of course, we want it at a certain speed. One of the failures, just to mention, that can happen, we have to have a certain idle RPM of the engine at starting. And if it's not happening, obviously there's something wrong. Either we have a weak starter, or there could be just other things going on there. But our objective is to have a certain idle RPM for the engine. So it has to be high enough of speed at starting. And also, like I mentioned before, about in flight. In flight could also be possible to have an air start if the pilot feels that there's a demand for that. Okay, so that's the start system. Okay, is we have that starter. We've got that start control valve. We have these shutoff valves. That's actually a shutoff valve, part of the pneumatic starter. Okay, and of course you have your controls and indications on the ECAM display. What you're going to find across any of the faults that occur is going to be the master caution warning coming on. There's going to be a single chime. It's going to be the same warning indication for any of the faults that I'm going to be mentioning later on. Also, keep in mind there are two modes of start: automatic and manual. Okay, automatic is run by FADEC. It's going to be receiving signals and being able to then give instruction, so that if there truly is a fault, then it's going to abort that start sequence. Okay, it'll shut off the fuel shutoff valves. Those will close, etc. So that happens in automatic start, which some of the things it's not going to happen in manual start. You're going to have to actually go through a sequence of actually executing to make that happen, to clear things. But automatic start, that's what you have. It's the ECU is going to open up the starter shutoff valve. You're going to have the igniter exciters, being energized in order to get to the igniters and getting that energy to those for starting. You're cranking. There are two kinds of cranks. I'll mention very briefly a little bit later, but just so you have a helicopter's view, there's only two crank modes that we'll be talking about. That's your dry crank and wet crank. Okay, just to be clear, dry crank is when there's no fuel flow. going through the combustion chamber, and wet crank obviously means that there is a fuel flow. So you got a liquid, okay, a fluid, as part of that sequence. Okay, your continuous ignition, that can also be selected by the ECU, or through the ECU. It can be done manually with the rotary selector, or it can be done automatically by the FADEC. Okay, so either way, automatic or manual, it's possible to have the continuous ignition. Okay. All right. Okay. So it kind of gives you an idea with the starting system in general, the spark igniter, exciter. Okay, exciter first because that gives that energy over to the igniters, and then just the controls and indications. How I'm saying that you're going to have the same warnings across the different faults that would be detected. All right, let's go into the first component. I'm going to be talking about the starter valve. They're called by different names. Do not let that throw you off if you see it written, differently or slightly differently, because it's the same thing. It's the start valve. Now, don't let that confuse you with the shut-off valve. There's the starter shut-off valve, and that's a separate valve. But the start valve can also be called an start air valve or a start control valve. The air starter control valve, just know it's the start valve. Okay, and what does this valve do? What do valves do? Okay, in general, well, they're controlling, they're regulating something. Okay, in this case we're talking about fuel flow or airflow. In this case, airflow, because we're talking about air starter. So we're talking about the control of a fluid. And air, by the way, is considered by definition a fluid. And this is what we're talking about here. So that's what that valve is doing. It's controlling that airflow to the starter. Okay. All right. Where is the start valve located? By the way, that's a test question. You may want to write that down in your notebook. Okay. Where is it? Where is it located? Okay. It's actually at the 3 o'clock position on the fan frame. And of course, it can't be far from the starter, so it is actually above the starter. Okay, at the 3 o'clock position. So that just kind of keep that in mind where that's located. Its normal position, where should it be, open or closed? Okay, it's going to be in a closed position. That's its beginning, before the start sequence begins. Okay, all right. So on the air starter control valve, just to give you a little description about it, certainly there's so many different kinds of valve configurations, in the engineering of it or design of it. And here with the control valve, there's 2 major sections to it. You have your valve body, and of course you have your air actuator, okay, to transmit that energy to the starter. So that's what this control valve has, is 2 different parts to it. It is electrically controlled, okay, by the electronic control unit. It also has, one of the biggest problems with valves is, or say biggest problems, one of the things you don't want to have is have it stick. Okay, and it can stick or be stuck because maybe there's ice. That's one possibility. So therefore, there is an air heating aspect to that valve, just to make sure that it doesn't, get stuck with ice buildup. So you have that. Part of the air, the inlet air, is actually going through an orifice, and it's going around a solenoid valve, and then it's vented to ambient. So just know part of that is happening with that air coming in to the valve. You also have a rotor that's obviously there to provide torque in order to drive that high pressure rotor through the reduction gear and the clutch assembly that's part of the valve. Okay, that all is going, part of that motor action that's controlled by the control valve in there. And then the manual backup, there is a manual backup system in case the air starter control valve doesn't work. Okay, now let's say, okay, now it's opened, because remember I said kind of at rest. I'm kind of using some classic physics terminology here, but at rest, okay, at its initial position, the control valve is closed, right? That's the test question. And then we start this sequence, and they open. Okay, so what happens when it's open? Now you have air that's let in, and that air is directed to the starter. Okay. The whole idea here with the starter, okay, with the component starter, I know I'm on control valve right now, but the starter is actually there to kind of get that engine moving. Okay, it's spooling it up. All right, back to this control valve. How long is it? What's the size of this thing? It's really not that big. The length of it's just over 8 inches. In height, it's about 11 inches, and the diameter is 4 inches, and it gives you an idea of the size of it. Okay. Now, in what you have in open position, when it's opened by energizing solenoids, and we talked about solenoid coils. If you've ever taken some other classes, you know, we're talking about solenoid coils that get energized in order for something else to open or to get moved. Okay. All right. Now that's automatic. We have automatic operation, and then there's the manual. With manual operation, which kind of a caution here, what you want to be aware of is you don't want to operate the valve manually when the valve is not pressurized. So just keep that in mind. The valve needs to be pressurized if you're going to be manipulating it. Otherwise, if you don't, you're going to damage the valve. Okay, and lubrication is important for anything that moves, okay, and in mechanics. The lubrication, there's a lubrication system that's a wet splash type that's operating, you know, under high temperatures. Okay, now as far as manually operating this thing, remember I said it has to be pressurized if you're going to be manipulating it by hand. Here you can actually rotate the handle to the open position on this valve. Okay, so that's how you do that, and again, just make sure it is pressurized. Okay. Just kind of a added piece of information. It's not critical for you to absolutely memorize or anything like that, but just know the starter valve has 2 pneumatic actuators in it. You know, depending on the sizes of valves, you may have 2 or 3 or 1, whatever actuators. This one in particular has 2. Okay. All right, so that's just your air starter control valve, your control valve, whatever. That then is providing, okay, air to the starter, which the starter is connected to the engine, so you have that, you know, that connection, that transfer of energy to get the engines spooled up. So now let's talk about the starter itself. Okay, so we have compressed air that rotates the starter turbine, okay, from that control, and then that control allows that opening of air to go to the starter, and that's going to be turning the gears that are in part of the starter. All of this is then creating torque. It's using that airflow in a certain configuration to have that high torque movement. Okay, and all of that's going where? Okay, if you think about where this thing is located, obviously you have the engine, you got also, what do you have? You know, we got the AGB. Your accessory gearbox, right, is all these here for the accessories, and starter is an accessory to the engine. So here we've got the transfer of this energy going to the AGB, your TGB, and also your IGBs. It's all connected. You know, your accessory gearbox gears to connected to your transfer gearbox, and then your internal gearbox. Okay, that's all, you know, there. Now, it will cut off at a certain point, because remember, it's kind of like almost like pushing somebody, I don't want to say a small person, I'm talking about like a child. Let's say you may be getting the bicycle moving, and then after a while, okay, it's on its own momentum. And it's kind of the same thing here. The starter will shut off or disconnect from the engine after start. Now, what's considered after start by definition? Okay, after start is defined as 50% of N2. So once it reaches that, then there's that disconnect. Okay, now there are operational limits. Okay, your operating limits for the engine starting, and this would be, you don't have to memorize this, but I do want to mention some numbers. But for maximum operating limits on your N1 and N2, those are going to be for, and on your N1, your low pressure compressor rotor is 102%. That's your max limit. The N2, your high pressure compressor rotor, That's at 105%. Now, also, what's important is exhaust gas temperature, and that's a fascinating thing with just understanding the dynamics between that and your engine RPMs, etc., and just kind of all the variables that go along with that. But here, just be aware that at start, the EGT max is at 725 degrees Celsius. Okay, that's Celsius, guys. Okay, Celsius. So we're going to be talking a little bit more of the failure, okay, a problem of the EGT exceeding. Like, we don't want to have that happen, but you know, it could. All right, the starter, where's that located? Okay, remember I mentioned about the control valve, starter control valve, where that's located, right? And it's above the starter. Now we have the starter. The starter's installed on the back side of the accessory gearbox. Okay, that's where that's at. All right. Okay, so it gives you an idea with that. Now there is a duty cycle with the starter, and it's important to note what the maximum number of cycles are. Okay, cycles, there's a duty cycle, and there's different ways you can actually have the cycles, but they are specifically defined, and it's important because you know, you don't want to have an exceedance of time. Time is very important. That it can be a problem. The starter acceptable duty cycle, here you have a maximum of 4 consecutive cycles of the engine starter, and that's within a 9-minute period. All right, that is a test question, by the way, is what's the maximum number of consecutive cycles can you have in a 9-minute period? Okay, the answer is 4. 4 consecutive cycles. Okay, and each of those cycles maxes at 2 minutes. Go up to 2 minutes max. Can't go any further than that. And then there has to be a rest in between, because if you keep running it continuously without rest, it's going to get hot. You know, you're trying to make sure you have some cool down in between, and that's why that 20-second rest in between. Okay, and then after the 4th cycle, you're going to allow more time for it to cool. So after that 4th time, it's going to be 15 minutes, you know, lapsing to cool that. And there's other different combinations, but I'm giving you the standard, you know, regular duty cycle, if you will. Also, what you want to be aware of is you don't want to keep re-engaging the starter, okay? Because you keep doing that, you'll ruin it, essentially. You do need to pay attention to that. Basically, what you want to do is not re-engage the starter above 20% of N2. Just, you know, that if you do that, you're going to damage the starter or the accessory gearbox. Okay, so just again follow the manual as far as the process and, you know, the schedule of when you can do a restart and re-engage that start. Okay. All right. There's the controls and indications, of course. What I want to mention at this point is some of the failures, and then we'll kind of go back to the system control. But I just wanted to kind of go over the failures, because remember, I mean, you see them there on the you know, display that you're looking at, and then we'll talk about that. But the starter failures, or remember I said you could have the EGT limits are exceeded. Okay, that's one. The high pressure fuel shutoff valves, you know, not opening or opening. You know, basically opening when they shouldn't, or they're not opening when they should. You know, so it's just a mixture of things. Let's say you have the high pressure fuel valve that doesn't open when it should, then you're going to have those oral warnings. Remember I said it's the same type of warning. You're going to have an oral warning, so you're going to have a single chime along with the master caution light that will come on, and the engine fault lights are going to come on as well. That's all going to show up on the ECAM as the ECAM messages. Now the FADEC, if you're on automatic, I'm talking about automatic mode, the FADEC is going to, you know, going to pick that up, and then it's going to abort the sequence. It's going to abort that. Okay, so basically what's going to do is it's going to start shutting that down. And then in manual, you know, it's the same thing about, you know, making sure you get the engine master switches off, and then release the manual start push button. And then you got to clear the ECAM control panel and then set that mode to norm. Remember, there's ignition start and you have norm as well. We want it in the norm position. Okay, so that's one fault, is having high pressure shutoff valves, not open. The starter time exceeded, you can have this fault where the starter time is exceeding what I mentioned earlier. If that happens, then of course the same warnings are going to come on, and the FADEC, if it were in automatic mode, it's going to go through that same process of shutting down that start sequence and having the master control switch be off, clearing the ECAM, and then setting that mode to the engine mode to norm position. Okay, so kind of a same process there. The other thing too is you have an ignition fault. Okay, that's another possible problem. It will go through 2 attempts. So 2 attempts is really your normal ignition, and then one more attempt, and that's it. So that's max attempts on the ignition fault if something's wrong with the ignition. Okay, now exhaust gas temperature over limit. Okay, and that also could include a stall. If there's a detection of a stall or the EGT over limit, the FADEC is going to be monitoring all that, and there's a maximum number of attempts that it's going to do before it aborts the start sequence, and that's going to be how many? It's going to be 4. Okay, 4 is the maximum. That's a test question, by the way. Okay, so just know it's going to do 4 attempts, including the initial attempt at it, trying it, before it'll actually abort. Okay, that whole thing. It's going to shut off the fuel shutoff valves are going to close, etc. So we don't want to have a problem with fuel still being, still flowing if there's that. So, okay, so that's what you know on that one. The information on that as far as the number of attempts. Now, what about a hung start? Okay, does anybody know what a hung start is? I'm not gonna, insult anybody's intelligence. At the same time, I don't want to leave some people out in the dark because I have not worked on engines. But a hung start situation is basically you're starting it up, but it's not translating to the engine. In other words, the engine's not getting to the idle RPMs that it needs to be. It's falling short for whatever reason, and that could be from a weak starter. That's just one possibility. But that's what a hung start is. You're doing everything there to get the start sequence going, but that engine's RPMs are not, it's not going up to where it needs to for idle. Okay. What's going to happen there, if you have a rich hung start, that means, remember, the fuel shutoff valves have opened, then you don't want to have that fuel flow continue at that, that flow rate or that amount. So what's going to happen is the ECU is going to give command for dropping that fuel flow, just 7%. So you're going to have a 7% reduction of fuel flow. If it's too lean of a hung start, okay, then what's going to happen here, if that is detected, then if the engine acceleration ceases, so we don't have the acceleration there, and there's been no reduction in the fuel schedule, and there's no over temperature, there's no stall, then the maintenance, if you're doing maintenance, whatever, then you have to abort the start. Okay, that's just one thing that can be done. Okay, but that's what a hung start is, and that can be, not enabling that whole start sequence to continue. All right. There's also an oil pressure, and I'll mention about the engine fire a little bit, and then we'll talk about wet and dry crank a little bit. But oil system malfunction. Oil pressure, okay, remember I mentioned about temperature, pressure, and quantity. Here, the oil system malfunction can be a problem. When it's really cold, you can have the oil pressure at 45 psi during the start. And then, of course, as things warm up, then, it can go over 90 psi at takeoff, and that's completely fine. The problem, though, is if the oil pressure is more than 90 psi during the steady state operation, okay, not at takeoff, steady state operation, it's usually an indication of something going wrong. Okay, then you have a problem. And there's going to be an indication of oil pressure problem. Okay, it depends on the fluctuation. And I definitely want to have Rick talk a little bit about this, because he can, he has stories to tell, by the way, that have happened over his 34 years of flying. So that will just come into play here and help you understand a little bit better about that. There's almost like a range that is sort of okay, but if the fluctuation's too much or too often, then definitely needs some attention. Okay. Oil is important. We're talking about engine oil. Very important that it needs to be corrected, because of course you can damage the engine itself. So it's very important. All right. And then what about engine fire? The internal engine fire. There is the post-shutdown burning. This can be identified as a failure of the EGT to go down, because EGT, there's different limits where after it's gone to a certain temperature, it needs to come down after X number of minutes. It needs to start coming down, and if it doesn't, then that's a potential problem with fire, etc. So here you've got the engine panel 115 VU. You select the mode selector switch to crank. Okay, there's also on the overhead 22 VU, you have the control and indication, okay, the CTL and IND panel. There's the push button for the engine manual start. Okay. Okay, that's the internal engine fire as far as what you do. Now, an external engine fire, if there's the warnings below here I'm going to share with you are going to be, they're going to be showing on display when there's an external engine fire. There's the overhead one warning display, okay, and there the engine fire push button will illuminate. You're going to have a repetitive chime that sounds, and your master warning lights are going to be on. Okay, so just to mention that, so you're familiar with that. There's a potential engine, when we talk about internal engine, external engine fire, as we're talking about, temperatures that might go up, it just whatever conditions that are causing that potential. Okay, now let's go a little bit on the engine crank. Okay, this is going to be engine wet crank and dry crank. And remember what I said, dry crank just means when there's no fuel flow, you don't have the fuel shutoff valves open. This is going to be at dry. The conditions are similar. Aircraft configuration is going to be that the APU is running, the APU bleed is on. Your FADEC is going to be on as well. It's going to be powered. Both the engines are shut down. Okay. All right. And as far as the duty cycle for the crank sequence, this is going to be 2 minutes on, 20 seconds off. Remember I said time to cool, so max 2 minutes for each cycle. There's four consecutive cycles. 2 minutes max, and then 20 seconds off for cooling, and then 2 minutes again. Okay. All right. Now, just kind of to understand a little bit about a kind of a process here. On the wet crank, that you're going to have the master control switch on the on, and that's going to be on between 15 and 20% of N2. Okay, and then after you have a wet crank of 15 seconds, then when the master control switch is set to off, then the fuel's cut off. Obviously, when you have master switches control off, then fuel shut off valves are going to be, that fuel's going to be cut off. Okay, and then there's going to be a resetting of the ECU. When that happens, then the starter shut-off valve. Can you remember I said the starter itself has its shut-off valve? That's going to open, and that's going to open when this is all kind. This is variable. Okay, variable just changes based on the N2 speed. Here, if the speed is less than 20%, that's when that command is going to happen for the starter SOV or shut-off valve to open. Okay, and then you have the dry crank that's initiated at that point. Okay, now the dry crank, when you have that condition, you continue that with the engine in that condition for 60 seconds. Okay, and that's going to allow that fuel to dry, whatever's there in the combustion chamber. Okay. Okay, so that's kind of the dry crank, wet crank story, if you will. Okay, and then just remember I mentioned, automatic, because you have automatic mode. You also have manual, and there's also continuous relight. And the continuous relight would be, a condition existing if you had the engine anti-icing switched to the on position. Okay, so that's what one condition. There's different ones. Okay, I think it's time for some test questions. Okay, all right, we got that. The start valve is hydraulically operated. By the way, there are some true and false questions besides multiple choice. Okay, here's the statement. The start valve is hydraulically operated. Is that true or false? Okay, that's false. So I just mentioned it's an air start valve. Okay, air. It's mentioned that it's air, so it's pneumatically operated. Okay, the start valve is electrically controlled. Is that true or false? Okay, that's true. Because what controls the start valve? It's the ECU. Okay, ECU is an electronic control unit, so they're doing it electronically, and obviously there's electrical energy with that. Okay, where is the starter located? Okay, is it A, the back side of the accessory box, or B, above the oil tank? Okay, you're right. It's the first answer, back side of the accessory gearbox. All right, what happens when you re-engage the starter after 20% into? Okay, option 1, the starter will disconnect from the engine within 2 minutes, or the starter will be damaged and possibly the gearbox. Okay, it's the second option, right? The starter will be damaged. You don't want to re-engage that starter after 20% into. All right, well, what is one condition that can cause a hot start? I mentioned hung start, and defining hot start, I hadn't done that yet, but here you're going to get it. Okay, hot start. Okay, think of hot start, think of hot fuel, because it just means you have almost like too much fuel at that point. You have too much fuel in the combustion chamber at that point, and at the same time, the engine RPMs are just not up to speed. Okay, so what is one condition that can cause a hot start? Is it low starter air pressure or high starter air pressure? Okay, it's low starter air pressure. Okay, what are two starter failures? Is it option A, the pack valves do not reopen and EGT overlimit, or high pressure fuel shutoff valve does not open and ignition fault? Okay, it's the last option. Okay, so those are two conditions. Ignition fault is one, and the other is that the high pressure fuel shutoff valve doesn't open. All right. Regarding starter limitations, how many continuous cycles can there be in the duty cycle of a 9-minute period? Okay, is it four continuous cycles or 5? Okay, I mentioned that it's 4. All right. All right, we got a couple more questions and then we're done with this. How many different engine crank modes are there? Is it 2 or 4? Okay, it's 2, right? I said there's dry crank and there's wet crank. All right, when in dry crank mode, both the LP, okay, your low pressure and high pressure fuel shutoff valves are opened. Is that true or false? Okay, I didn't mention that now, but now you're going to get it. It's actually true. When in dry crank mode, both of those shutoff valves are opened. All right, last question. What is the maximum number of start attempts, including initial attempt, when an EGT overlimit is detected? Okay, is it 3 or 4? It's the maximum number of start attempts. Okay, it's 4. It goes maximum of 4 attempts before then. If it can't, so if it doesn't start, then it aborts the start sequence. Okay. All right. So I hope that gives you an idea, gives you some familiarity with the engine starting. Just to recap, like I like to do, is we covered the two biggest components we're talking about is the start air valve, or it can be called by another name, a couple of other names, starter control valve. It's basically the valve that allows air, okay, to flow to the starter. That's the second component. The starter is there kind of to spool up the engine to certain RPMs, kind of get things moving, and that's your second component is the starter itself. The starter, just to give a little bit of so you remember a little bit, is split into two sections. Okay, you got the valve body and you have actuators. Okay, actuators as well. We also talked about some of the failures that can occur, you know, with starting. Ignition fault, of course, your hung start, hot start. You can have an engine stall. So when the compressor's rotor's not up to speed, it's not you know, going at the right RPMs. You can have the EGT, so engine exhaust temperature, that's too high, so you have an exceedance there. You also have this, another fault could be that the starter time is exceeding. It's going past what, you know, how much it should be, you know, to actually start. So that's a fault right there. Okay, so we covered some of those. Automatic start, manual start, your continuous relight, and then just kind of mentioning the controls and indications that you can find on the eCam, and also knowing that there's a single chime master caution lights come on, as well as the engine fault lights that come on when there is a fault. Okay, so that gives you a rundown for the most part of the engine starting. If you have any questions, please feel free to email us and we'll be happy to answer those questions. And I look forward to sharing other lessons with you.